This is what the reference sheet looks like. Okay, so if you want to, like, these are the arithmetic formulas. This is to find AN, and this is to find the sum. These are your shortcuts, which you do not need to know. You can just plug in, but they will help you for time purposes. So, like, if you see something that's just a variable here, okay, then you can use the n times n plus 1 over 2. If you see something that's squared, you can use the n times n plus 1 times 2n plus 1 over 6. And then if there's a number on the front of those, you can bump it to the front. So you can do that little formula, you could multiply it all out, and then you can multiply by the coefficient that's on the front. Or you can take and plug in. So it depends, I would say for time purposes, there's not going to be anything that's too big that you can't do arithmetic or geometric with. Yeah. If it is, the count would be so small enough that you could plug in. Okay. Yeah. And then these are your geometric. So the first one is the AN formula or the N formula for geometric. The second is for a finite set. And the last one is for an infinite set. Okay. And then we added to this the other day. We said the way to find the arithmetic if you don't have not given consecutive terms, that we would do the value of the bigger one minus the value of the smaller one over the actual big number minus the small number. So if I gave you, I didn't do an example, so I don't know if this is going to work, but let's say I give you A10 is 25 and A3 is negative 3. I would do 25 minus a negative 3, which becomes 28, over 10 minus 3. So I would get over 7, and this would be 4. And that tells you what D is. Yep. No. Only what you see there in print is given. That's for geometric. So that's if this is arithmetic. Then if not given consecutive terms, geometric, this is when you do A big equals A small raised, no, R times R to the big minus small. So let's say, I'm not going to give you a value because this definitely won't work out. But let's say I give you A7 equals something, and then I give you A3 equals something. You would do A7 on the left equals A3 R to the fourth. And then you would plug in the values that you have. Usually in that case, then you're going to solve for R, and you're going to have to, like, in this case, you would fourth root it at the end. Yeah. Sure. Yeah.
Going back to the shortcuts one.
Yeah.
What would you do if it was I cubed?
So that's a different shortcut, and it's not going to be given to you. So I would say I wouldn't use a shortcut. It's going to be a small enough range that you could take the bottom number, plug it in until you hit the top number, and then add them together at the end. Which is the same for all those shortcuts. Like if the bottom number is 1 and the top number is 5, I would plug in 1, then plug in 2, then plug in 3, then plug in 4, then plug in 5.
But you couldn't use the geometric.
Not if it's cubed.
But if it's squared, you can.
No, actually, if it's cubed, you can. No, the exponent has to be an I for it to be geometric.
Okay.
Does that make sense?
Yeah.
Yeah, the exponent has to be the variable for it to be geometric. Yeah.
For the squared one, what if it was like 3 minus 2I squared? Like,
You could break it apart. So if it's, let's just say it's this to make it easy. What do you say? 3 minus 2I squared. So you could break this apart to I equals 3 minus I equals 1. The 2 can go to the front, I squared, and then 3 at the top. So then you can use this for that part. So I would get 3, because 3 minus 1, like the n is 3, right? 3 times 3 plus 1 times 2 times 3 plus 1 over 6. And then whatever I get from there, 14, gets multiplied by the 2. So I'm subtracting 28. And then this one we just multiply out 9. And that would be negative 19. Honestly, if it's 3 terms, I'd just plug it in. I'd plug in 1, then plug in 2, then plug in 3, and add them together at the end. Yeah, I wouldn't overcomplicate it if you can avoid it. Yeah. Yeah, if you're adding or subtracting, you can split them to use a shortcut. And remember, you can only use a shortcut if the bottom number is 1. If the bottom number is not 1, you can't use those shortcuts. All right, so the first one was find the first 5 terms of this in the sequence. So you plug in 1, you plug in 2, you plug in 3, you plug in 4, you plug in 5. You should have gotten negative 4/3, negative 3/5, negative 2/7, negative 1/9, and 0. I would say most of you did this one pretty well. Any questions on that one before I go to the next one? So plug in 1, plug in 2, plug in 3, plug in 4, plug in 5, and get them in that order. Yeah. Sure. Sorry. All right, to evaluate the series. So this is one of the ones where I would say it's easier to just plug it in, because you can't use a shortcut here. The bottom number is not 1, so you can't split it. You can't use a shortcut. So you would start by plugging in the 3. So I plug in 3. I'd get 2 times 3 plus 3. Then I'd plug in the 4. 2 times 4 plus 3. Then I'd plug in the 5. 2 times 5 plus 3. And then I'd plug in the 6. 2 times 6 plus 3. And I'd get 6 plus 3, which is 9. 8 plus 3, which is 11. 10 plus 3, which is 13. And 12 plus 3, which is 15. And then I'd add them all together, and you'd get 48. Because this is arithmetic, only because it's a plus or minus, right? So, or a single term by itself. Because it's arithmetic, you could also have done n over 2 times first plus last. So the n is 6 minus 3 plus 1, which is 4. 4 over 2, or 2. The first, I take the 3 and plug it in. We already did it here. It's 9. The last, we take the 6 and plug it in. We did it over here. It's 15. And I would get 2 times 24, which is 48. So same thing. Only because it's arithmetic, you can do it both ways. Yep. Sure. Yep. Why do you plug it? Yeah. Okay. All right, the third one was this. So this is a scenario where obviously I would want to start at the 0 and go all the way up to the 30. You are going to get ones that are big like that, but it's arithmetic. So because it's arithmetic, I would use the formula. So n over 2 times first plus last. How do you know it's arithmetic? Addition, or just multiplication. So multiplication, or multiplication with addition, or just addition, okay? No powers, no fractions, nothing like that, okay? Unless it was like n plus 1/2, that you could do. All right, so now my n is 30 minus 0 plus 1, so it's 31. The first, I take 0, plug it in. 2 times 0 plus 4 is 4. The last, I take 30, plug it in, so it's 60 plus 4, which is 64. This is 1054 when you multiply it out. Questions on that one? All right, 4, find the formula for AN given the sequence is arithmetic, and A22 equals 54 and A45 is 100. Then find A1 and S100. So this is where you're going to, because you were not given consecutive integers, you're going to use that little formula. So the first thing is, well, the equation is AN equals A1 plus D times N minus 1. I don't know A1 and I don't know D. So I'm going to do 100 minus 54 over 45 minus 22. So 100 minus 54, 46, over 23, and I get 2. Now I have that part, 2 times n minus 1. I still don't know a1. So I have to use one of the ones that's given to me. And I can use either one, but let's say I use a22. If I put a22 on the left, it would equal a1 plus 2 times 22 is the n, minus 1, and a22 is 54. Hi. All right, so 54 equals a1 plus 2 times 21. 54 equals a1 plus 42, and a1 equals 12. Now I have my a1, so I can do my equation. an equals 12 plus 2 times n minus 1. That's one of the things they asked for, right? They said find an. So if this is a multi-part question, you've got to pay attention. Like maybe underline what it's asking for in your instructions so you don't miss any parts.
Is it wrong if you factor it out?
What do you mean?
Like if it becomes an equals 2n plus 10?
No. If I was giving that as an answer, I would keep going. an 12 plus 2n minus 2. an would equal 10 plus 2n. That's how I'd prefer it if it asked for it as part of an answer. If you're just using it to get to something, which it does this time, it asks for it as part of the answer. So I would prefer it that way. If it's just asking you to use it, then you don't have to go to that step. But if you're giving it on the actual number line as an answer, you want to make sure you simplify it like that.
How do you get a1?
I did this. So I did a22 on the left equals a1 plus 2. If it's a22, then my n is 22. So you have to find d first and then plug it into the formula with a22 on the left. Similarly to how we do that geometric with the big on the left and the small on the right, except we don't know a1. So a22 goes on the left, a1 plus 2 times 22 minus 1 because you know n.
How would you know like what value to put?
It doesn't matter, actually. I could have done the same thing with a45. So I could have done a45 equals a1 plus 2. Well, here, I'll use this equation now. This one, 10 plus 2 times, now it would be 45. Oh, no, I can't use that equation yet. Sorry, just kidding. You didn't have that equation yet. You had a1 plus 2 times 45 minus 1. And then a45 is 100. So then I'd get 100 equals a1 plus 2 times 44. 100 equals a1 plus 88. And a1 is still 12.
So the n is going to be
The big one's on the left. Yep. And then the number is the base on that number. Yep. You do big minus small over the base on the big minus the base on the small. Yeah. Yeah.
Do you do like 2 times 1? What's the difference between 2 and 1 is 1 and then
Yeah, you could work backwards like we do here. Sure. And then from there, so we got A1, and then it wants the sum of the, so S100 means the sum of the first 100 terms of this sequence. So it'd be n over 2 times first plus last. N is 100 over 2. The first one is the A1, which is 12. The last, this time, we have to find A100. So I would use this one. A100 equals 10 plus 2 times 100. 10 plus 200, or 210. So 50 times 222, right? Yep, 11,100.
So n is the final, the extent of the summation.
S, you mean this one?
Well, no, like.
Oh, the
n.
base on here. So this notation means find the sum of the 100th term, first 100 terms in this. So that is your n. Yep, the number of terms in it. Yep. You find the sum, right? Given of the first 100 terms. So it's 100 over 2 because it's 100 terms. The first is your A1, which is 12, and then we just found a 100, which is 210. So you plug 100 into the equation that you got from here. And that's your A100. Or your last. God bless you. So if I had said find S50, what changes? Now it's 50 over 2. The first is still 12, right? But now the last is A50. So you have to find A50. 100 plus 2 times 50. 10, sorry. Times plus 2 times 50. This is 110. So this would be 25 times 122, which is 3,050. So this one had multiple parts. Like, this is a pain in the butt question, but it could happen, so you want to make sure you know how to do all those parts. Questions on that one? All right. Find the sum of the first 20 multiples of 4. Would this be arithmetic or geometric? If I go 4, then I go 8, then I go 12, then I go 16. Arithmetic or geometric? Arithmetic. You're adding 4 each time, right? So this is arithmetic. And we're finding the sum of an arithmetic. So n over 2, first plus last. Huh? You way overthought it, right? How many terms are there in the first 20 multiples of 4? 20. The last is 80. Yeah. The first multiple of 4 is 4. The 20th multiple of 4 is 80. Huh? You didn't do 80?
How'd you get 80?
Oh, 4 times 20. Right? 20 multiples of 4 is the 20th multiple of 4. Yeah. First multiple of 4 is 1 times 4. Second multiple of 4 is 2 times 4. So if you want the 20th, you go 20 times 4. Okay? If you're unsure, then you could literally find A sub n. A1 would be 4, right? The D is 4 because it increases by 4 each time. N minus 1. So if I wanted to find the 20th one, I would do 4 plus 4 times 20 minus 1. 4 plus 4 times 19. 4 times 19 is 76 plus 4 is 80. So if you don't trust your instincts, set yourself up in arithmetic, find whatever term it is. We said if it was, obviously the multiples you just multiply out. We said if we're talking about, right, because it's not in here, if it said consecutive even integers, so if there's the first 20 consecutive even integers, 20 is your n, 20 over 2. The first even integer is what? 2. What's the 20th even integer? 20 times 2, 40. If it said consecutive odd integers, okay, again, let's say the first 20. What's the total terms? 20. What's the first odd integer? 1. How do you find the 20th consecutive odd?
39.
So you want to double it and subtract 1. Double it would be even, right? And then it's 1 less than that, because if the first even is 2 and the first odd is 1, you move back 1. So this would be 39. Okay? You can also do 2n plus 1. It's the same thing. No, 2n minus 1. That's like from your shortcuts. Okay? But I think it's easier just to remember that. And again, if you are unsure, these are arithmetic. an would equal, for the first one, my a1 is 2. From 2 to 4 to 6, what's d? 2, n minus 1. For an, if it's odd, what's your a1? 1. From 1 to 3 to 5, what's your n? Or what's your d? Still 2. So you could also say, I'm going to take 20 and plug it in here, and I'd get the same answer. But I think evens are easy, just double them. Odds, double it, subtract the 1. All right, this one, and again it says evaluate the series. That means find the summation. Okay, the 5 should have been at the top. The I equals 1 should have been at the bottom. PowerPoint was being difficult the other day. What kind of series is this? Geometric and finite. If you did not want to use the formula and it's 5 terms, this one's not terrible. You could plug in 1, you could plug in 2, you could plug in 3, you could plug in 4, you could plug in 5 and add them all together. The yucky part is they're all going to have a different denominator, so you're going to have to find a least common denominator, which is where the formulas are way easier, okay? Finite geometric is A1 times, what's the rest of this formula? 1 minus r to the n over 1 minus r. Good. A1, if I take and plug in 1, would be 125, 2/5 to the first. 5 goes into 125, 25 times, and 25 times 2 is 50. So A1 is 50. 1 minus my r is 2/5. The r is what's being raised to the power. What's the number of terms here? 5 over 1 minus 2/5. Instead of going all the way through. So I would raise 2 to the 5th. I would raise 5 to the 5th. I get 50. 1 minus, this is 32 over 3,125. This would be 5/5. So this would be 3/5. This is 3,125 over 3,125. I get 50 times 3,093 over 3,125 over 3/5. And then keep change flip. So this is gone. 5 goes into here, 625, 3 goes into here, 1031. And then I can actually simplify this further. 25 and 25, this is 2 and 25. And you get 2,062 over 25. It has to be left that way. So this is the danger of your calculator. If you convert that to a fraction, if you use your calculator too much and get that into a decimal form, it's going to get marked wrong. You've got to make sure you keep it exact. Yep.
So on the test, since there's so many fractions and all that, if we do the work right and we get the wrong answer, it's still right.
Is it still right? No. May there be partial credit? Probably. Will there be mercy points? Probably. But you're not going to get all the credit.
I was doing like last night and I put the square somewhere else.
Just be careful. Better is just get it right. Better plan. Yeah. Yes, there would be probably be partial credit. All right, this one says evaluate 2 plus 2/3 plus 2/9 plus 2 over 27. Okay? And find a sub n for the sequence. So first of all, what kind of sequence is it if it has a dot, dot, dot at the end? It's infinite. So the dot, 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 where it doesn't say find the specific number of terms in this sequence, right? If it said find the first 100 terms in this sequence, then that's still finite. But this one just says evaluate and you're adding it up with the dot, dot, dot. This would be infinite. And in order to find an infinite, r, or the absolute value of r, has to be in between 0 and 1. So I want to then look and see what r is. So 2/3 divided by 2 would be multiplied by half, and this is 1/3. So because this is in between 0 and 1, I can do it. If it was not, you can't even do it to begin with. So this is my r. If it's an infinite geometric, it's A1 over 1 minus r. A1 is 2, 1 minus 1/3. This is 3/3. This is 2 over 2/3. And then we keep change flip, and my answer is 3. Then it says find an for the sequence. So an would equal a1 r to the n minus 1 because it's geometric. A1 is the first term, which is 2. R is 3. Nope, sorry, r is 1/3 to the n minus 1. So it asks for those two parts. Questions on that one? Yeah. The 3 is the sum. It's the infinite sum. All right, 8. Find A1 and R for the geometric sequence given A4 is 5 and A7 is 5/8. So this is the one where it's geometric, right? That's important. And it jumps. So if it jumps, I'm going to put the bigger base on the left. A7 goes on the left. A4 on the right. R is going to be raised to what power? 3. So this is 5/8 equals 5 times r to the third. Divide both sides by 5 or multiply by a fifth. I get 1/8 equals r to the third. Cube root it, and I get r equals 1/2. That's the r. Then I have to find A1, and you can use either one. I'd obviously recommend the one that's closest to the A1, to the A4. A4 on the left, A1 on the right, r would be raised to the third power. So if A4 is 5, A1's my unknown, 1/2 raised to the third, 5 equals A1 times 1/8, multiply by 8 on both sides, and A1 is 40. Yeah? Good? Okay. All right, 9, this is your factorial. Remember I said break it down from the larger till it hits the smaller. So 11 times 10 times 9 times 8 factorial over 8 factorial. These cancel, and then I just do 10 times 11 times 9, which is 990.
So should you go back to say
1, what's bigger, n plus 2 or n minus 1? N plus 2, so I do n plus 2 times n plus 1 times n minus 1 factorial. So you break it down until it hits that n minus 1 factorial, and then these cancel out, and this is what's left. You can totally leave it like that, or you could FOIL it out. N to the third plus 3n squared plus 2n would have been the answer. Either one. I will leave it. Save yourself some extra work.
Will there ever be the bigger number in the?
In the bottom? Sure. It just would have been 1 over this.
Yeah.
Yeah. All right, so I posted the review. I would say start it. Remember, it would be better. There's a lot on there, so I don't need you to do it all tonight. You can do it tonight, between tonight and tomorrow. But I'm not with you Thursday, so the more you know what you need help with tomorrow, the better off we're going to be. And then make sure you bring whatever calculator you plan to use on Friday with you tomorrow.